by a net external force. In essence, it describes the tendency of objects to maintain their current state of motion. The lab test results in calculated change of position and observed change of position. I use models from GlowScript and Tracker, which here's my Tracker video, and then here's my GlowScript video, to get the observed and calculated values. I assume no net force after the initial push, which would show that the ball has a constant velocity because of Newton's first law. In this lab, the system is the ball and the surroundings is everything else, so the table and the air around the ball. In this, the ball starts at t = 0 and x = 0 as seen in the Tracker video. The ball is then rolled across the table with no net force after the beginning push. The ball could have been pushed out of line with camera, causing the appearance of it slowing down when it was just not lined up correctly. And this is the GlowScript code I used to calculate my GlowScript video. I made the delta t 1/60 because in the Tracker video it runs at 60 frames per second, and I made my final time 1.668 seconds because the Tracker resulted in 1.668 seconds. And then here is my observed data on the left and my computational data on the right. The computational data on the is double the amount of values because I accidentally changed the rate and doubled the amount of times it would be calculated. Here are my position and time graphs. The blue is the observed values and the orange is the computed values. You can see the blue is not very accurate and it falls off a little bit at the very end. That's because of the possible friction that the table exerted onto the ball, but the orange one is completely straight because it was computed. Now my what if. I will talk about the main what if in this lab is what if the axes were changed in Tracker. The displacement of the value would be the same, but the direction it would be different. If in the video it was lined up to where let me get back to the video. If it was lined up to where the axis were like this or like this, the displacement would still be the same length of the line. It would just be cosine or sine of however like far of theta of the angle. And then that would give you the values like seen. It'd be the same displacement but different. Like it could be negative if it was in the left direction or down, but it would still be the same total displacement. So, and then next is, what does it mean when net force equals 0? That net force equals 0 means that all forces acting upon the object cancel out, like seen in this free body diagram. So there's a force normal, force gravity, force applied, force friction. In this one, they all cancel out to be 0. So whatever velocity or speed or motion this object has, it will stay in it until this force is changed. We can determine the amount of pushes and pulls if given the situation. For example, we assume there was no friction and air resistance in this lab, but if there was minimal, which caused the calculated data to be just a little bit more than the observed. In an object flying through the sky, we know that there is drag, gravity, and possibly thrust, which we'd have to calculate into this free body diagram. Thank you. That's all.